And then what's the next thing we're supposed to do? It says here, after you reflect it over the line, x equals 2, then we're going to rotate 180 degrees about the center at 2, 3. Okay, the center is not going to be the origin now. It's going to be at 2, 3. So where is the 2, 3? The x is 2 and y is 1, 2, 3. Here is a pivot point in which, if you could imagine, this is like a clear, transparent screen film, and the whole thing rotates 180 degrees. Where would that be? Well, it's going to be on the opposite direction. So now I'm going to make this, I don't mean to make it complicated, but I want to help you visualize this. Check this out. What I'm going to do, remember, in a circle, if you have a center, and if you were to draw a radius, and if you draw a radius to the opposite side forming a straight angle, the whole thing becomes a diameter. And the diameter is in fact a straight angle of 180 degrees. That's the 180 degrees rotation. So that means if I took that point C and draw a radius to the center and extend it to the other side, that's going to become a diameter of a rotation circle. So how do I know where to stop? What I'm going to do is now use a compass. And I'm going to match out the radius of the C point. And using my pivot point, I'm going to rotate this guy 180 degrees. Ta-da! There it is. And where do I stop the rotation? On the opposite side of the diameter. So this is where I stop. This is my new location of the C. And I'm going to mark that as a C prime, because that's a new location of the initial one that started over here before the reflection. Now I'm going to do the same thing with A, the new location of the A. I'm going to draw a line through the center, right there. And I'm going to extend that out as well. And I'm going to rotate that. Oops, there we go. Well, what do you know? It's going to be pretty similar to where the other guy was. Oh, but it changed. There we go. See that? See that? There we go. And then we're going to rotate this guy this way. Kind of. There we go. Now we're going to go hiya, ya, 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 hiya, hiya, hiya. And where does this guy stop? Well, I think it's supposed to be like, let's see, around here somewhere. Okay? And that's a new location, A. So that's going to be the A prime. And where is this far away B going to be? That's going to be a doozy, huh? But to do that, I'm going to draw a line from that pivot point, that vertex, to the center, and extend it out all the way to the other side. Like that. And I'm going to rotate that guy. That's going to be a good travel. There we go, right here. Let me tighten up this guy right here so it doesn't move around. There. And then, let's rotate that. Here we go. Woo! Yeah, baby. Look at that. Right over there. And where do I stop? On the opposite side of the diameter. Now I got my, and that's going to be C prime as well. So I draw the lines between those three new vertices. And what I should have is an exact same shape, but it's going to be in a different location again. There it is. And that becomes A prime, B, where am I? B prime. I did not write the B prime, I guess. No, this is the B prime. There we go. Phew. B prime and the C prime. So now we're going to do the last part of this Friday challenge that I gave to my students. and go ahead and label the vertices of the final transformation and label it as A prime, B prime, and C prime. And then we'll prove the congruence to see that the isometry has been and demonstrated by using the distance formula again between the distance, this time the new A and the B. Okay, so here we go. So the new locations for, let's see here, where was I? This was a C reflected over here, that's a C, and once it's been rotated, this is a C. So the new location for C prime is going to be, what do you know, at 0, 0. And the B was over way off there, reflected to come over on this side, and then rotated 180 degrees, and this is going to be the new B prime. And the location for that is, let's see, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So it is -8 and -4. And finally, the A, which used to be over here, A initial, -1 and 2, has been reflected over to this side, 5 and 2, and then rotated 180 degrees, way out there. And the new location for it, I hope you don't get confused here, it is at -1 and 1, 2, 3, 4. Now, if this is the same shape that came from the rotation and the reflection, the distance between the A and B should be the same as the distance A prime, B prime. So we're going to prove that by going the distance formula, x2 minus x1 squared plus y2 minus y1 squared. I'm going to label that as x1, y1, the B prime, and the post image, A prime, is going to be -1 and 4. So x1, y1, x2, y2. So x2 is -1 minus x1 is -8. We're going to square that. Plus y2 is 4 minus y1 is -4. And we're going to square that and square root the whole sum. So now that becomes -1 plus 8 is 7 squared. Plus 4 minus negative is plus 4 is 8 squared. That's going to become 49 plus 64. And look at this. That also becomes square root of 113. Voila! So even though the position or the polygon, the triangle, reflected and rotated, it moved from the initial position, the size and the shape has been maintained and has been proven by the distance between the A prime and B prime, and it should be all congruent for every distance between all the vertices. So here it is. I hope you enjoyed that. Good luck!